So, have you ever wanted to create an AI that has a very specific personality? Imagine you are working for a travel agency. You don't want just any chatbot, right? You want one that is super friendly, helpful, and has a tone of voice that truly represents your brand. You want your assistant, not some generic robot. Well, that's exactly what fine tuning is all about. It allows you to take a powerful general purpose AI and teach it to behave exactly the way you want. Alright, let's jump in. We are going to walk through the entire process step by step. First, we'll answer the big question: when should you even fine tune? Then, we will cover preparing your data, choosing a base model, configuring the job, and finally, evaluating the results. And remember, this whole workflow is very important for the AI-102 exam. So, let's make sure you fully understand it. Before you even think about fine tuning, you need to be 100% sure it is the right tool for the job. It's powerful, but it's not a magic solution for everything. You have three main approaches. First, prompt engineering. This should always be your starting point. It's fast and simple. Second, retrieval augmented generation or RAG. If your model needs access to up to date facts or company specific knowledge, RAG is the better solution. But if your main goal is consistency, consistent tone, consistent style, consistent formatting, that is the sweet spot for the fine tuning. Fine tuning lets you bake your brand personality directly into the model. Now, we are at the most critical step of the entire process. And I'm not exaggerating. The quality of your final model depends almost entirely on the quality of your training data. Garbage in, garbage out. Your data must be formatted as JSON lines or JSONL. That simply means every line in your file is a separate JSON object. Each object represents one training example, one small lesson you are teaching the AI. Inside each object, you will define a list of messages. Each message has a role and a content. The system role defines the assistant's behavior. The user role contains the question. And the assistant role contains the ideal answer you want the model to learn. That system user assistant structure is the foundation of your training data. You can even include multi turn conversations to teach the context. There is also a powerful feature called the weight parameter. For example, you might set the weight of one assistant response to 0. That tells the model to ignore it during training. Then you assign weight 1 to the response you actually want it to learn from. This gives you very precise control over what the model absorbs. And here is the most important takeaway: focus on quality, not quantity. A few hundred clean, high quality examples are far better than thousands of messy ones. And always remove any personal or sensitive information before training. Once your data is ready, it's time to select a base model from the Microsoft Foundry model catalog. You are not building an AI from scratch. You are building on top of a powerful pre-trained foundation model. When choosing a model, filter by task, look for chat completion models. Make sure the model is available in your Azure region and always read the model card. The model card tells you what the model is good at, what data it was trained on, and any known limitations or biases. Now it's time to configure the fine tuning job inside the Microsoft Foundry portal. The process is straightforward. First, select your base model. Second, upload your training dataset. Optionally, provide a validation dataset. Then, configure the advanced settings, also known as hyperparameters. These are important, especially for the exam. Epochs determine how many times the model reads through your dataset. Batch size defines how many examples are processed at once. The learning rate multiplier controls how fast the model adapts. If it is too high, the model may skip important details. If it is too low, training becomes very slow. Finally, the seed value ensures reproducibility. Running the same job again with the same seed gives consistent results. Once everything looks good, you submit the job and wait for training to complete. After training finishes, you deploy the model. Deployment creates a unique API endpoint specifically for your fine tuned model. Now comes the real test. Send prompts to the endpoint, check the tone, check consistency, verify formatting. Does it behave the way you trained it to? If yes, congratulations. You now have a customized AI model ready to integrate into your application. So, let's summarize the core idea. Fine tuning is for teaching style and behavior. RAG is for providing external knowledge and facts. And the most powerful AI system often combines both. Now that you know how to shape a model's personality, think about this. What could you build if you combine a perfectly tuned model with a rich knowledge base? That's where things get really exciting.